Hi, Assalamualaikum. My name is Nur Azma binti Hamka. My metric number is DB240070. I want to present about definition of a limit. The concept of a limit allows us to analyze the behavior of a function as the input value x approaches a specific point. Even the limit enables us to determine the value that the function is tending toward. In this example, we examine the function x squared 2 plus 2x minus 3 over x minus 1 as x approaches 1. From the table and mathematical notation, the table demonstrates that as x approach 1 from both the left hand side and the right hand side, the corresponding function value converge toward 4. Using mathematical notation, both the left hand limit and the right hand limit yield the same value, which is 4. Therefore, although the function is undefined at x equal 1, the limit exists and is equal to 4.
Assalamualaikum warahmatullahi wabarakatuh. My name is Elena Zlaika binti Muhammad Rafi'i. My metric number is DB240189. So today I will explain about one-side limit. One-side limit consider what value a function approaches as the input approach a point from only one direction. The right-hand limit, lim xa plus fx, look at value of x greater than a, while the left-hand limit, lim xa minus fx, look at value of x less than a. A limit lim xa fx exists only if both one-side limit exists and are equal. One-side limit are especially useful when analyzing piecewise function or discontinuities. So this is the example for one-side limit, left and right. This is to determine if a general limit exists at a given point. We will compare two distinct examples from the figure provided. Okay, let's look at the figure 2.1 at the point x equal to 3. As we approach x equal to 3 from the left, x3 minus the function of value fx approach 2. And as we approach x equal to 3 from the right, x3 minus fx also approach 2. Lim 3 plus fx equal to 2. Since the left limit and the right limit are the same, the overall limit exists, which is lim x3 fx equal of 2. So for now, let's examine figure 2.2 at the point x equal to 4. This show a jump discontinuity. As we approach x equal to 4 from the left, x4 minus fx approach minus 2. However, as we approach x equals 4 from the right, x4 plus fx approach 4. Because the left limit, negative 2, is not equal to the right limit, 4. The overall limit does not exist at this point. In summary, a limit only exists if the function approach the same value from the left and the right direction.
What is an infinite limit? An infinite limit happens when the value of a function grows larger and larger without bounds towards positive infinite or decrease without bounds towards negative infinite as the inputs get closer to a specific number. In simple words, the function do not approach finite numbers. Instead, it shoot up forever or down forever. Infinite limit often occur near vertical asymptotes. This is an example of infinite limits. Example 1. Positive infinite limit. Consider the function fx equal 1 over x minus 2. The limit as x approach 2 from the right. 1 over x minus 2 equal to positive infinite.
Limits law. What's a limits law? Limits law are the rules that simplify calculating limit of complex functions by breaking them down into the simple parts. Process limits laws. Example limits law. Use a limits law to evaluate the limit x equals 4 to x power by 2 minus 5x over x minus 1. Sorry. First one, apply equation law. Check the numerator first. Leave x equals 4, x minus 1 equal 4 minus 1 minus 3 and equal 0. For example, a limb x equals 4, 2x over by 2 minus 5x over limb x equals 4, x minus 1. To apply different law to the number and denominator. Limb x equals 4, 2x minus power by 2 minus limb x equals 4, 5x over limb x equals 4, x minus limb x equals 4, 1. And 3. Apply constant multiple law to the terms. Like limb x equals 4x power by 2 minus 5 x equals 4 limb x equals 4x minus limb x equals 4 1. And 4. Apply power law, identity law, and constant law. 2 dot limb x equals 4x over by 2 minus 5 dot limb x equals 4x over limb x equals 4x minus 5x equals 4 1. And second step goes 2 dot 4 power by 2 minus 5 1 dot 4 over 4 minus 1 and calculate the result 2 dot 60 minus 20 over 3 equal 32 minus 20 over 3 equal 12 over 3 equal 4. So the limit is 4.
So, squeeze theorem. What is squeeze theorem? The squeeze theorem is a principle used in calculus to confirm the limit of a function by comparing it with two other functions that have non-equal limit at a specific point. Mathematically, this is expressed as is fx smaller than gx smaller than hf for all x near c, and limit fx is L and the limit hf is L, then lim gx also L. It is typically usefulness to find the limit of the function that are difficult to evaluate directly, especially involving trigonometric function.
Question 1. Evaluates limit x apostrophe x power of 2 minus 9 over x minus 3. Step 1. Factor the numerator. X power of 2 minus 9 equal to x minus 3 x plus 3. Thus the limits become limits apostrophe x plus apostrophe x minus 3 x plus 3 over x minus 3. Step 2. Cancel the common factor, so x minus 3 x minus 3 can be cancelled. So it becomes limits x approach 3 x plus 3. Step 3 is substitute x plus x equal to 3. Now substitute the x plus 3 equal to 3 plus 3 equal to 9 equal to 6.
Okay, alright. Let value the limit x 0 since x per x. If we attempt direction substitution x equal to 0, we get the indeterminate from since 0 per 0, which is 0 per 0. However, this particular limit is a standard fundamental trigonometric limit result. Based on the squeeze theorem and established calculation rules, the value of the limit lim 0 sin x per x is always equal to 1. Therefore, the value of this limit is 1.
Question number 3. Evaluate limit x approach infinity. 5x power by 2 minus x plus 1 over 2x power by 2 plus 7. Step 1. Divide by the highest power of x power by 2 into the denominator. The highest power of x power 2 appear in both the numerator and denominator. So divide both the numerator and denominator by x power by 2. And education 5x power by 2 minus x plus 1 over 2x power by 2 plus 7 equal 5 minus 1 over x plus 1 over 2 power by x over 2 plus 11 over x power by 2. Step 2. Take the limit as x approach infinity. The term 1 over x, 1 over x power by 2, and all approach 0. Thus, the expression simply 2, like 5 minus 0 plus 0 over 2 plus 0 equal 5 over 2. Sorry. So the value of the limit is 5 over 2. Thank you.
Okay, for this function, we are asked to find the limit of the function as x approaches 2 from the right. The function is limit as x approaches 2 from the right of 1 over x square minus x minus 2. Step 1. Factor the denominator. First, we factor the denominator. The expression x square minus x minus 2 can be factored into. So the function becomes x minus 2 times x plus 1. Okay, step 2. Analyze the behavior of the function. Now we look at what happened as x approaches 2 from the right. As x positive 2, the term x minus 2 is a small positive number. The term x plus 1 is close to 3, which is positive number. So the denominator is a small positive number time a positive number, making the entire fraction very large and positive. So the limit as x approaches 2 from the right is positive infinity. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. Today I will tell you guys about how to use the squeeze theorem to evaluate lim at consider sine 1 per x equal to 0. Evaluate the limit of the left and the right function as x equal to 0. Like the photo below. So x consider sama dengan 0. The squeeze theorem, the middle function must also be 0. So the value of the limit is 0.
Real-world application. Instantaneous speed. How limit involves in this situation. For instantaneous speed, the concept of a limit is used in the real world. An object speed constantly changes over time. To find the exact speed at a particular moment, we calculate the average speed over smaller and smaller time intervals. As this interval approaches zero, the average speed approaches a specific value, which is the instantaneous speed. What the limit represents? The limit represents the exact rate of the change of an object position with respect to the time at that moment. It is also the slope of the tangent line on the object's position versus time graph. At that point, a car's speed meter is a real-world tool that approximates this, this limit by showing instantaneous speed.